Okay, so now we're going to do Chapter 4, applying the metric measurements and calculating doses. So our presentation topics are going to be basic metric units, conversions within the metric system, problem solving in the pharmacy, and customized doses. So I'm just going to go through, you can read through these learning objectives. But we're going to start at section 4.1, so identifying, of course, the metric units of measure, using metric prefixes and abbreviations. So the metric units of measure that we're going to go over are going to be your three basic ones, which is going to be meter, gram, and liter. So those are the three that we'll talk about mostly in pharmacy calculations. So right here you have the three basic units of measure. Meter is abbreviated with M, gram is abbreviated with G, and liter is abbreviated with a capital L. Okay, so meter, what you're going to measure here, is this going to be associated and you're going to be measuring length. Grams, you're going to be measuring weight in grams. Liters, you're measuring volume. Okay, so one thing, with liters, we're using it to measure liquids, such as like your liquid medications, liquids for solutions. The grams, of course, we're measuring the amount of medication in a unit form. The meter is the only one in pharmacy that has limited use. Okay, so meter has limited use in pharmacy calculations. Sometimes you will hear us talk about it every now and then, but the main two that we're going to talk about mostly are the gram and the liter. Okay. So a metric system is a measurement system based on subdivisions and multiples of 10, made up of three basic units, meter, gram, and liter. So a meter, of course, is the basic unit for measuring length in the metric system, and these are things that I've already went over. The gram is the basic unit for measuring weight, and liter is the basic unit for measuring volume or liquids. So it is important to memorize your units, and memorize, of course, also along with their prefixes as well. So identifying metric units of measure, 1 gram is the weight of 1 cube centimeter of water at 4 degrees Celsius. Another way to identify it is 1 liter. If you converted it over to milliliters, 1 liter equals 1,000 milliliters. Okay. With cc's, always is the same as the milliliters. If you have 1 milliliter, it's going to be 1 cc's. If you have 12 milliliters, it's going to also equal 12 cc's. If you have 110 milliliters, you're going to have 110 cc's. Okay. This is a question I know that on some state boards they always ask, and it confuses people if they have not went over it. But one way to think about it is if it says cc's, think of it as also milliliters, because it has the same volume. Okay, so 110 milliliters would equal like 110 cc's, cubic centimeters. So next here you have some of your metric prefixes and their values. And it gives you the abbreviations, your nanos N, micro MC, milli M, centa C, deci D, and kilo K. Mostly here you may see micro MC. So if it's microgram, it's going to be MCG. If it's micro liters, it'll be MCL. Okay, so it's usually 1/millionth of the basic unit. Milli, it's going to be 1,000th. So if you have, depending on if it's liters, it'd be milliliters. If it's grams, it might be milligrams. Okay. Centi, of course, is 1/100th of the basic unit. Deci, of course, is going to be 1/10th of the basic unit. Sometimes we'll talk about the centa and the deci, and the kilo, of course, is a 1,000 times the basic unit. And we'll actually go over these on the next few slides as we're going through problems. So your volume, of course, are commonly going to be used to measure liquids, are going to be the following. You have, I'm sorry, parts of a unit are going to be written as the decimal fractions, and for example, 2.5 milligrams is written as 2.5 milligrams. You could also say, of course, 1/2 milligram would equal 0.5 milligrams. Okay, because there is no whole number, you will need to add a leading zero. So for a half, it's actually 0.5, but you would add that leading zero because it is not a whole number. So weight, these are our units of weight that we're going to talk about, are commonly used to measure weights in pharmacy. That's going to be your kilogram, your gram, milligram, and your microgram. So if you look at here, usually, I'll teach you a table if it's not in our notes already, what I use to go by when I'm doing converting. But milligrams would be like 1,000 milligrams. Micrograms would be a million. 1 gram, and then 0.001 kilogram. Okay, and I'm going to set that up in a chart later on to kind of give you an idea. So the volume is going to be kiloliter, liter, milliliter. Remember, milliliter is the same thing as your cc's, cubic centimeters, and your microliter. Okay, so remember, kilo is always going to be 0.001 to start with. That's what it refers to. Liter, 1. Milliliters is going to be 1,000, and microliters would be a million. Okay, so if you notice on the previous slide, I did the same thing, but it was with grams. Same thing with the the liters. So what you're going by is this number is actually referring to the abbreviation. Milli, 1,000 milli, 1 million would be micro. Same with length. Oops. Kilo, 0.001. It's kilometers. Just meter by itself would be 1. Milliliter be 1,000. Micrometer, because it's micro, it's going to be a million. And this information is going to be useful just in conversions. So if you look here, you're looking at just the boxes showing you how to use the metric prefixes and abbreviations. So this amount of pasta is equivalent to 1 gram. Okay, so this picture is just there to give you a visualization of the size of an object. So a kilogram is equivalent to a little more than 2 1-pound boxes of pasta. Okay, next you have these 3 paper clips to show you a visualization of what weight is for 2 grams of weight. Is about equivalency. One large paperclip, of course, is going to weigh about 1 gram. 2 small weights are going to measure about 1 gram. So all 3 of these paper clips together should measure about 2 grams. So it's kind of give you an idea of how just to visualize the weight of an object. Again, this bottle, of course, contains 2 liters of liquid. Usually in the bottles, they're written out in ounces, sometimes in milliliters as well. So that's where your conversions later on will come in. So using the metric prefixes and abbreviations for a decimal value less than 1, use a leading zero to prevent any errors. So in other words, if it is not a whole number, you will use a leading zero to keep from making mistakes. So again, my example earlier was 1/2, which is 0.5, and so you would add that leading zero. Same thing with 1/4 is going to be 0.25, and you would put that leading zero. So pharmacy technicians should use the medication labels, not the color or shape of the pills, to confirm the amount of drug contained in a tablet or capsule. This right here is just showing you the levothyroxine uses colors to help differentiate the strengths of pills. So if you notice here, like the 25 microgram is orange, the 50 microgram is going to be white, 75 microgram will be violet. So this is to help people, but if you notice, they all say levothyroxine on them. So this is to help pharmacists and pharmacy technicians to realize if they have the right medication or not, just another way of differentiating the milligrams with a different color tablet to help to prevent errors. So if you look in your book on page 80, you have some questions that I'm just going to kind of go over. Problem set 4.1, if you look at the questions 1 through 10, and I'm not going to do all these. All you're having to do is state the abbreviation for each of the following units. So microgram is going to be MCG. That was number 1. Liter is number 3. It'd be a L. Okay. Number 9, cubic centimeters is CC. Okay. So that's all you're having to do is you need to just go through there and put the abbreviations for the following. Next, if you look at numbers 11, 12, and 14, what you're supposed to do is write the following numbers using an Arabic number, of course, with a decimal value and the appropriate abbreviation with it. So if you look at number 11, it says 6/10 of a gram. Okay, so you know it's not a whole number, and then you go to the 10th spot, so it says 6/10 of a gram. And you put, because it's not a whole number, you want to put your leading zero there. Okay. Number 12, 50 kilograms. Okay. This is a whole number, so it would just be 50, an abbreviation for kilograms. Drop down to number 14. If you look at number 14, it says 4/100 of a liter. So, you know it's not a whole number, so you're going to have your leading zero. And you got to go to the 100th spot. So 10th is first, 100th is next, so you would put your 4 there, and in front of it you would have a 0. And then put your unit of measure, which is liters. So those are some examples on 11 through 20. Now next we'll do some samples of your applications. So if you look at number 21, okay, I told you earlier I was going to kind of give you a little bit of a tip on doing conversions, okay. But if you read number 21, it says that Taro Pharmaceutical Company has donated a container labeled 5 kilogram of bulk maxicillin granules. The standard dose is 375 milligrams. How many single dose units can be obtained from the container? So if you notice when you, I'll write that out actually. Let's see here. If you'll give me just a moment. Okay, there's why I wanted to go ahead and write it out. Is just to look at what the what the container label has is in kilograms, and the standard dose is 375 milligrams. How many single dose units can be obtained? So the thing to do would actually be to first convert your 5 kilograms over to milligrams, because that's what the standard dose is in milligrams. Okay, so in order to do that, I do the cross, which is an old-fashioned way of doing it. And then I always go back to, you have 5 kilograms. If you have kilograms up here, then it's going to be a little bit different than your ratio of proportions. The kilogram unit is going to be directly opposite of it in the corner. Okay, and this one right here is going to be what you want. So you want it in milligrams. Okay, so you just ignore the grams, and if it says milli, you know it's 1,000. If it's kilograms, you know it's 0.001. Okay, so then all you have to do for this one, we're in the ratio proportion, you cross multiply. This one you're multiplying across and then dividing. So 5 times 1,000 would be 5,000 divided by 0.001, which is going to give you 5 million milligrams. Okay, so okay, so you have your 5 million milligrams in milligrams. So you're going to take your 5 million that you've converted your 5 grams over to 5 million milligrams. Okay, and then you're going to divide it by the standard dose, which is 375 milligrams. And that would actually convert over to, or what you divide 5 million by 375 per each the standard dose. The number of single doses or units that can be obtained are going to be 13,333. It actually continues, but we would just round that off to 13,333 single doses. If you looked at this discussion, these are on number 24 of your book. Okay, so a patient is to receive or to take 1.2 grams of cimetidine per day in 4 divided doses. Which drug label would be chosen? So first thing you want to do is you're going to look down here and you notice these are in milligrams. Okay, you have it in grams. So what would be the first thing you would need to do? You would need to convert your grams over to milligrams. So you would take 1.2 grams, and I call this my little handy dandy cross. If you have grams here, you're going to put grams here. You're wanting milligrams, so milligrams will go here. Okay, and then to get your two numbers for your cross is if it says milli, it's 1,000. If it's 1 unit by itself, it don't have anything in front of it, it's always 1. Okay, so then you take 1.2 times it by 1,000, and you get 1,200 milligrams divided by 1, which would be 1,200 milligrams. Okay, then you want it to be divided into 4 divided doses. So all you do is you take 1,200 and divide it by the 4 doses, and it should come up 300. So this would be the one that you would pick, the one with the 300 milligrams. Okay, that would be the end of section 4.1, and I'll make a different recording for section 4.2.